integrating real-world crypto payments. I am technical lead at the AMPera Foundation. For those of you who don't know, the foundation has led the creation of the AMPera digital asset spending movement, as well as created the upcoming Anvil protocol, a DeFi primitive for collateral and collateralization use cases. A little about me. I've been working in crypto for 6 years, but this is my first time at ETH Denver, so I'm excited to be here and be part of this community. Previously, I was the founding engineer at payments company Slide. Slide was then acquired by Raise.com, a gift card marketplace that has processed billions of dollars in sales, where I was an engineering lead. After that, I was the technical co-founder at Flexa, the largest pure digital payments network. And now I lead open source spending projects for the AMPera Foundation. This all means I've been working on some version of digital payments specifically for more than 10 years, which is frankly shocking to me. Mind blown. My goal in this space is and always has been to help and enable the spending of any asset on any app anywhere in the world. To date, tech that I've worked on has enabled almost 100 Ethereum assets to be spendable both in store and online at merchants as varied as Chipotle, Nordstrom, Dunkin', and Sheetz. My companies also went live powering the largest bank and payment provider for Bitcoin in El Salvador. We have a rapidly growing user base of hundreds of thousands of spenders, some of which you can see here. From these experiences building digital asset payment systems, it's clear to me that the biggest issue in this space is that we need a better crypto UX. Calling it the biggest issue we face may sound hyperbolic, but it's not. User experience is the largest barrier to mainstream adoption of our technology, both for consumers and merchants. Pay with crypto can be a transformative, the ability to pay with and unlock additional value and capability of any type of digital asset. But ultimately, it needs to be as simple, safe, and secure as the de facto payment methods the masses are used to. Like quickly paying with cash, or scanning and tapping to pay. With over 1 billion global users of mobile payment apps like WeChat Pay, Paytm, and Venmo, the world is ripe for crypto payments to completely take over the system, but not without achieving parity with these status quo payment technologies. The good news is we can. It's motivating to see that we are currently pacing growth with the internet itself. To win, we will need continuous improvements in things like scale and legal clarity, of which I'm sure there are many experts here with us at ETH Denver. However, we cannot afford to overlook the user's experience. In order to solve the hard stuff, you need to make the easy stuff easy. To be clear, there are indeed a lot of hard things that need solving in crypto, like the aforementioned scale and legal clarity. And these are hard in crypto payments too. Not to mention the 15 million different point-of-sale systems to integrate with, merchant e-commerce and logistics platforms, etc. For payments, though, interoperability is the most important thing. Just like any phone can call any other phone and any browser can access a website, we need to ensure the same principle applies for crypto payments. To start, has anyone heard of CAIP2 or CAIP19? The Chain Agnostic Standards Alliance, CASA, an open source collaboration between organizations like MetaMask, Wallet Connect, Ledger, among others, understood that with the development of new Layer 2 solutions like rollups and sidechains and the growth of multi-chain systems, multi-chain architecture is a first-class citizen. Similar to the EIPs that we know and love, CAIPs are chain-agnostic improvement proposals. CAIP2 was created to consistently and deterministically identify chains, and CAIP19 was created to do the same for assets. Why was this needed? Wallet clients want to and often support different blockchains. Otherwise, users would need a different wallet to interact with every chain, which may seem normal for those in this room, but becomes untenable for the average user. Unfortunately, there is no native way to universally identify a given blockchain. For instance, because of their identical consensus mechanisms, Bitcoin and Litecoin are identified by their Genesis block hashes. Using Genesis hashes to distinguish between Bitcoin and its forks was codified in BIP 122. For Ethereum, EIP 155 was proposed and implemented in response to the DAO fork in order to prevent replay attacks. It was at this moment that a chain ID was introduced to differentiate EVM-compatible blockchains, a concept widely adopted by chains such as Optimism, Polygon, and Avalanche, among others. Further complicating these matters, in a non-EVM chain, there is no protocol-level mechanism for a wallet to know what asset is what. For instance, USDC is currently active on 15 different networks. Try explaining to your grandmother what version of USDC they are trying to spend with. So the CAIP 19 proposal, building upon CAIP 2, was created to standardize asset identification into a machine-readable, human-understandable, deterministic, and developer-friendly format. Importantly, CAIP 19 handles both fungible and non-fungible assets. This is the specification. Easy. Putting that together, here's a real-world example for how we would use the CAIP 19 to identify a CryptoKitties NFT. First, we define the ecosystem. CryptoKitties NFTs are on the Ethereum blockchain, identified by EIP 155, or identifier EIP 155 is used for all EVM-compatible blockchains. We determine the chain ID, in this case Ethereum mainnet 1. The asset namespace for EVM chains is the token standard. And for NFTs, that's going to be ERC 721. The asset reference is the smart contract address in this case. And then finally, we use the token ID because CryptoKitties are NFTs and non-fungible tokens have an individual ID. For ERC20s, we don't worry about that one. CASA, which governs CAIPs, encourages collaboration. The proposals are flexible, allowing communities for each chain to agree on identifiers that work within the frameworks and proposed changes. This helps new chains more easily adopt the methodology and avoid situations like the one seen here. Having a universal, deterministic, and generally applicable standard to identify something as basic as the assets involved in a transaction is table stakes for mass adoption of crypto payments. Now that we have a way to talk about chains and assets, how do we ensure our wallet clients can function with our apps? Well, in the olden days, there was only one browser wallet, and it used a thing called Window Ethereum, and it was okay. Then there were more wallets and more browser extensions, and EIP 1193 was created to attempt to get them to all play nice with Window Ethereum. EIP 1193 did some things right, so people wrote good docs for their browser wallets, and they really did try. But as I'm sure many dApp developers here can attest, it's a huge pain to figure out which key on Window Ethereum was used for which browser wallet using console log, and frustrating the chicanery that could be done with a rogue set timeout. The result was an unpredictable and crummy user experience, and not a much better developer experience. Multiple wallets clobbering each other in a race to the bottom, with users having to disable browser extensions to get the wallet they wanted to connect. I don't think Amazon was going to turn on its checkout page into a dApp under this kind of duress. With more and more EVM-compatible wallets being released every day, this was an untenable conflict. That is, until EIP 6963, multi-injected provider discovery was introduced. What EIP 6963 does is define a new channel of communication between apps and browser wallets that allows available wallets to be discoverable and for multiple wallets to coexist within the dApp, all by using native JavaScript concepts like event listeners and events. This pattern eliminates the aforementioned conflicts while also enabling wallets to inject their own metadata, such as wallet name, logo, UUID, and a reverse DNS entry. This additional information now allows apps to automatically display the wallet's canonical name and logo in their UI, bringing not just user choice, but stability, clarity, and predictability across contexts. The implementation is simple. Here we see a wallet, in this context known as the provider. The wallet announces itself via the global window event bus and listens for additional requests for its EIP 6963 provider info. And here's the implementation for a dApp. We emit an event to request provider info, listen for providers to announce themselves, and build up our collection of available wallets. Ultimately, these ideas affect all wallets, all dApps, and most importantly, all of our users. Whoa. These are just a couple of the easy things that we can do in the name of interoperability that make our user experiences and our developer experiences that much better. The adoption of crypto depends on cooperation between different parties, and standards are an important building block for this cooperation. As developers, you have the power to make this happen. If we want to do the hard stuff, let's first make the easy stuff easy. And that's it. Thank you.